Good evening, students. Today I am going to explain soil classification, Indian soil classification. So, as per Indian soil classification system, how do we classify the soil? So, if we classify the soil, easily we can judge the engineering properties as well as index properties of the soil mass. So, depending upon the classification, the soil behavior can be judged. So, if soil is classified, then we can plan which type of foundation is suitable and which type of ground technique we need to go for. So, these things can be judged based on the classification of soil mass. So, in Indian soil classification, we have two classification. One is Indian soil classification system based on particle size only. Based on particle size only. Indian soil classification system based on particle size only. Second one is Indian soil classification system based on particle size as well as Atterberg limits. So particle size as well as we can consider the Atterberg limits also, liquid limit, plastic limit and plasticity index. So these three we will consider. So that classification and also IS classification only particle size. We don't consider the Atterberg limits, only we consider the particle size only. So let us discuss the first one, Indian soil classification system based on particle size only. IS Indian soil classification based on particle size only. So see this table column. So classification is based on grain size only. We don't consider Atterberg limits. Only grain size only. So the soil is given names like clay, silt, sand, gravel, cobble, boulder based on the grain size. Suppose if the particle size is less than 2 microns, the soil is classified as clay or colloid. Sometimes it is called as colloid because it is called as colloid because it is in Brownian motion. When the colloid is in the water, it is in Brownian motion. Brownian motion means it will move in downward direction. At the same time, it will move in upward direction, but it will not settle. So it is continuously in motion. It will not settle to the bottom of the vessel. So it will move in downward direction. It will move in upward direction, but it will not settle down. So that is known as Brownian motion. So when the particle size is less than 2 microns, it is known as clay. When the particle size is greater than 2 microns and less than 75 microns, then the soil is classified as silt. When the soil is greater than 2 micron size and less than 75 micron size, then the soil is classified as silt. So when the soil has particle size in between 75 microns and 0.425 millimeters, then it is called as fine sand. If the particle size is greater than 75 microns and less than 0.425 millimeters, then the soil is called as fine sand. If the particle size is greater than 0.425 mm and less than 2 mm, it is called as medium sand. If the particle size is greater than 2 mm and less than 4.75 mm, then the soil is classified as coarse sand. Coarse sand. If the particle size is greater than 4.75 mm, if the particle size is greater than 4.75 mm and less than 80 mm, then the soil is treated as gravel. So see the particle size 4.75 mm and 80 mm. If the particle size is greater than 4.75 mm and less than 80 mm, the soil is classified as gravel. Gravel. If the particle size is greater than 80 mm and less than 300 mm, then the soil is termed as cobble. Cobble. If the soil particle size is greater than 300 mm, then the soil is treated as boulder. Boulder. So 1 mm equal to 1000 microns. If you change that to microns into mm, you need to divide with the 1000. Suppose 2 microns, 2 by 1000, it will give in mm. So here my questions. It is a great question. What is the maximum size of clay? What is the maximum size of clay? Here the maximum size of clay is 2 microns. What is the minimum size of silt? The minimum size of silt is 2 microns. What is the maximum size of silt? The maximum size of silt is 75 microns. What is the minimum size of gravel? 4.75 mm. What is the maximum size of sand? 4.75 mm. What is the maximum size of gravel? 80 mm. The minimum size of cobble? 80 mm. The maximum size of cobble? 300 mm. The minimum size of boulder is 300 mm. Like that, you need to remember. Here, I don't consider any outer bug limits, liquid limit or plastic limit or any other outer bug limits. I don't consider here. That's why this Indian soil classification system is based on particle size only. This is one classification. So if you come to second classification, the classification of coarse grained soil. So if anybody is taken some soil to our laboratory, then we need to first find the which type of soil it is. So first we need to differentiate the soil. So which soil it is, coarse grained soil or fine grained soil. So take a sieve. What is the sieve size? 75 microns. So take a 75 micron IS sieve and sieve the soil. Take kg 1 kg soil mass and sieve through 75 micron ISU, Indian Standard Sieve. If more than 50% of soil is retained on 75 micron ISU, suppose you have taken 1 kg soil, that means 1000 grams. So 700 grams retained on 75 micron ISU. 700 means more than 50%. 50% 1 kg. In 1 kg, 150% means 500 grams. Here 700 grams retained on 75 micron ISU. So more than 50% of soil is retained on 75 micron ISU. So the soil is classified as coarse grained soil. If more than 50% of soil is retained on 75 micron ISU, then it is called as coarse grained soil. This is the first classification. So if suppose if more than 50% of soil passes through the 75 micron ISU, more than 50% of soil, that means you have taken 1 kg, 1000 grams of soil, 700 grams passes through the 75 micron ISU, then the soil is classified as fine grained soil. Fine grained soil. So that's why first we need to differentiate, which we need to classify the soil, which type of it is. So is it a coarse grained soil or fine grained soil? So if more than 50% of soil is retained on 75 micron ISU, it is called as coarse grained soil. If more than 50% of soil passes through the 75 micron ISU, it is called as fine grained soil. So now I am taking the classification of coarse grained soil. So let us imagine 700 grams, 700 grams retained on 75 micron ISU. So the soil is treated as coarse grained soil. So now in coarse grained soil, again we can divide the soil into gravel or sand. The soil is classified into two types, gravel, sand. So how can we differentiate? Now we need to take 75 micron, 4.75 mm Indian standard sieve. So in order to differentiate coarse grain and fine grain, I have taken 75 micron ISC. In order to differentiate whether it is a gravel or sand, now I am taking 4.75 mm Indian standard sieve. So if more than 50% of coarser fraction, here coarser fraction means the soil retained on 75 micron ISU. How much retained? So let us imagine it is a 700 grams. If more than 50% of coarser fraction retained on 4.75 mm ISU, then it is called as gravel. More than 50% of coarser fraction. So how much coarser fraction it is? 700 grams. 700 grams, 50% means 350. 350 grams. So more than 50%, suppose 400 grams is retained on 4.75 mm, then the soil is treated as gravel. Suppose more than 50% of coarser fraction passes through the 4.75 mm ISU, then it is called as sand. Then it is called as sand. That is the criteria. So in order to differentiate whether it is a coarse grain soil or fine grain soil, what is the criteria? 75 micron ISU. So in order to differentiate whether it is gravel or sand, what is the criteria here? 4.75 mm ISU. If greater than 50% of coarser fraction, so don't take a total soil mass. Greater than 50% of coarser fraction means the soil retained on 75 micron ISU. So we have already imagined that 700 grams is retained on 75 micron sieve. So we have taken 1 kg grams in 1 kg soil. In 1 kg soil, 700 grams retained on 75 micron ISU. This 700 grams is known as coarser fraction. So if more than 50% of coarser fraction is retained on 4.75 mm ISU, it is called as gravel. If more than 50% of coarser fraction passes through the 4.75 mm ISU, then it is called as sand. So in order to differentiate whether it is a gravel or sand, we need to take 4.75 mm ISU. So imagine more than 50% of coarser fraction retained on 4.75 mm ISU. Now the soil is treated as gravel. Okay, so according to our classification, treated as gravel. So again, gravel is divided into two types: clean gravel, gravel with fines. Clean gravel means fine particles. That means soil passing through 75 micron ISU. If less than 5%, that means soil passing through 75 microns means it is clay or silt node. If silt and clay percentage is less than 5%, the silt and clay is known as fines. If the silt and clay percentage is less than 5% in that gravel, then the gravel is treated as clean gravel. If the gravel contains fines less than 5%, it is called as clean gravel. Next, gravel with fines. If the percentage of silt and clay is greater than 5% within that gravel, then it is known as gravel with fines. Because it is a basically gravel, but the gravel is mixed with some sort of fines. If the percentage of fine is less than 5%, it is known as clean gravel. Clean gravel. That means the gravel doesn't have any fines. So gravel with fines means it is basically gravel, but the gravel is mixed with some percentage of fines. That fines is greater than 5%. So gravel with fines. So gravel is there. Along with gravel, some percentage of fines also there. So if fines is less than 5%, that gravel is treated as clean gravel. If the fines percent is greater than 5%, it is treated as gravel with fines. Suppose if the fines is less than 5%, then clean gravel again divided into two types: well graded gravel and poorly graded gravel. So when it is called as well graded gravel, coefficient of uniformity is greater than 4, and coefficient of curvature is in between 1 and 3. So already you know that coefficient of uniformity is equal to d60 by d10. So coefficient of curvature is equal to d30 square by d60 into d10. So if Cu is greater than 4 and Cc lies in between 1 and 3, it is called as well graded gravel. It is called as well graded gravel. It is denoted by GW. So while telling, we need to say well graded gravel. While writing, reverse order: gravel GW. But while telling, in reverse order we need to tell well graded gravel GW. Well graded gravel. Suppose these two requirements are not satisfied, that means not meeting the gradation requirements. These two requirements are not meted, then the soil is treated as poorly graded soil. The soil is treated as poorly graded soil. Next, suppose fines is greater than 5%. So fines is present in the gravel. So the fines may be silt, the fines may be clay. So we need to classify again, so that we need to find out the liquid limit and plastic limit. Then we need to find out the plasticity index. So plasticity index is equal to liquid limit minus plastic limit. So if plasticity index is less than 4, then the gravel is called as silty gravel. If the plasticity index is less than 4, the gravel is called as silty gravel. Basically, it is a gravel, but the gravel is mixed with some percentage of silt. So when it is called as silt, when plasticity index is less than 4. If the plasticity index is greater than 7, then the gravel is called as clayey gravel. When the plasticity index greater than 7, the fine is known as fines are known as clay. So basically it is a gravel, but the gravel is mixed with some percentage of clay. So when plastic index is greater than 7, it is called as clayey gravel. When the plastic index is less than 4, then the gravel is called as silty gravel. Silty gravel. So IP, we should compare the IP value. So this is about gravel, classification of gravel. So in the similar fashion, if greater than 50% of coarser fraction passes through 4.75 mm ISU, then again sand is divided to two types: clean sand, sand with fines. When it is called as clean sand, when fines are less than 5%. When fines are greater than 5%, greater than 12%, sorry, fines are less than 5%. In second category, fines are greater than 12%. 12%. So when it is called as clean sand, when fines are less than 5%. When the sand called as sand with fines, when fines are greater than 12%. So suppose it is a clean sand, fines are less than 5%. So again we have two classifications: well graded sand and poorly graded sand. So for well graded sand, the gradation requirements are Cu should be greater than 6, coefficient of uniformity is greater than 6, coefficient of curvature should be in between 1 and 3. Then the sand is called as well graded sand. It is denoted by SW, well graded sand. If these two gradation requirements is not meeting, then the sand is called as poorly graded sand. Poorly graded sand, SP, poorly graded sand. The sand with fines, when it is called as sand with fines, when fines is greater than 12%. So the small correction is there. It is not 5%, it is a 12%. So when fines are greater than 12%, then it is called as sand with fines. So fines means it may be silt or it may be clay. We need to find out. So we need to find out first liquid limit, then plastic limit. Then we need to find out the plasticity index. If plasticity index is less than 4, then it is classified as silty sand. Silty sand. If plasticity index is greater than 7, then it is called as clayey sand. Clayey sand, SC. Clayey sand. So here we have two doubts, two clarifications. Sir, suppose if fines is less than 5%, it is called as clean gravel. If fines is greater than 12%, it is called as gravel with fines. Suppose if fines is in between 5 to 12%, how can we classify? So now we need to go for two classifications. We will check the two classifications. One is clean gravel, another one is gravel with fines. So first to find, check the clean gravel. Suppose if you get GW, then again check the second one, gravel with fines. Suppose if you get GM, then you need to connect with a symbol GW hyphen GM, dual symbol. It is called as dual symbol. You need to connect GW hyphen and GM. So when fines is less than 5%, clean gravel. When fines is greater than 5%, gravel with 12%, gravel with fines. Suppose if fines is in between these two, 5 and 12%, then we need to check the first criteria as well as second criteria. Clean gravel we need to check, and also gravel with fines also we need to check. Then we need to indicate with a dual symbol. So in first one, we will suppose we will get GW. In second one, we got GC. Then dual symbol is GW and GC. So similarly, when plasticity index is less than 4, it is called as silty gravel. When plasticity index is greater than 7, it is called as clayey gravel. Suppose if the plasticity index is 5, then again here we need to indicate with a dual symbol GM hyphen GC. GM hyphen GC. That means the soil is silty gravel as well as clayey gravel. So the gravel is mixed with silt as well as clay. That is the meaning. So another one is clayey gravel, which is the most predominant. So it is a great question. Clayey gravel, which is predominant, which will be more percentage. So basically it is a gravel, clayey gravel. Basically it is a gravel. Percentage of gravel is more. Gravel is predominant, but it consists of a small percentage of clay. So clayey gravel means gravel is more, clay is less. Silty gravel means gravel is more, silt is less. Next, clayey sand means sand is more, clay is less. Silty sand, sand is more. Predominant it is a sand. It consists of some sort of silt. So like that, we need to classify the coarse grain soil. So important points. If fines falls between 5 to 12%. Here I have written fines greater than 5%, but it is a 12%. Please check it as a 12%. So if fines falls between 5 to 12%, then we have to use the dual symbol. Then if plasticity index falls between 4 to 7, then we have to use dual symbol GM and GC. Clayey gravel means predominantly it is a gravel but contains small percentage of clay. So problem. So let us see how to classify the problem. So classify the soil by the following data. 75% of soil retained on 75 micron ISU. What is the meaning? 75% of soil means more than 50%. So more than 50% of soil is retained on 75 micron ISU. So it is a coarse grained soil. So from this data, we can identify it is a coarse grained soil. Next, 60% of coarser fraction retained on 4.75 mm ISU. So 60%, that means more than 50% of coarser fraction retained on 4.75 mm ISU. So what it indicates? It is a gravel. So more than 50% retained on 4.75 mm ISU. Then the soil is classified as gravel. So here Cu value is given and Cc value also given. Cu value 5, Cc value 2. So there is no information about fines. If fines are there, definitely he will give liquid limit and plastic limit. So no data regarding liquid limit and plastic limit. So directly we can go for gravel, clean gravel. Clean gravel వెళ్ళిపోవచ్చు. We can go for clean gravel. In clean gravel, what is the Ce value? Ce value is equal to 5. Cc value is equal to 2. So Ce value greater than 4. It is a gravel. Cc value lies in between 1 and 3. So well graded. So the soil is classified as well graded gravel GW. The soil is classified as well graded gravel GW. So second problem. So classify the soil with the following data. So 40% of soil passes through 75 micron ISU. So 40% of soil passes through means more than 50% is retained on 75 micron ISU. So more than 50%, 40% means 60% soil retained on 75 micron ISU. Hence it is a coarse grained soil. So 20% of coarser fraction passes through 4.75 mm ISU. 20% of coarser fraction passes through means 80% is retained on 4.75 mm ISU. So more than 50% is retained on 4.75 mm ISU. Hence it is called as gravel. Okay. Next, so the gravel consists of some fines. Hence, he has given liquid limit 35%, plastic limit 25. So find out the plasticity index. So 35 minus 25 equal to 10%. So 10% means plasticity index is greater than 7. So when plasticity is greater than 7, the fine is classified as clay. So it is a gravel, but gravel consists of clay. So it is indicated as clayey gravel GC. So next problem. So classify the soil with the following data. So 75% of soil is retained on 75 micron ISU. So more than 50% retained on 75 micron ISU. Hence the soil is treated as coarse grained soil. The 65% of coarser fraction passes through 4.75 mmc. So 65% passes through 4.75 mmc. Hence it is called as sand. So no liquid limit, no plastic limit. That means sand is a clean, no fines. It is a clean sand. So clean sand. So then Cu value equal to 7, Cc value is equal to 2. So for sand, what is the gradation requirement? It should be greater than 6. For sand, Cu is equal to greater than 6. S, C is equal to 7. So Cc should be lies in between 1 and 3. So Cc value equal to 2. It lies in between 1 and 3. Hence it is a well graded sand. So the soil is treated as classified as well graded sand. SW graded sand. So another problem, classify the soil with the following data. 30% of soil passes through 75 micron ISU. So 30% of soil passes through. That means more than 50% is retained on 75 micron ISU. So it is called as a coarse grained soil. So 20% of soil is retained on 4.75 ISU. So 20% retained means 80% passes. 80% more than 50% of soil is passes through the 4.75 ISU. So 4.75 ISU, the soil is passing. So it is called as sand. So sand, plastic limit equal to 25, liquid limit is equal to 28. So plasticity index is equal to 3. So IP is less than 4. So it is called as silt. So the soil is classified as silty sand. So basically it is a sand, but it consists of some sort of silt. Hence it is called as silty sand. So another problem, classify the soil with the following data. 70% of soil retained on 75 micron ISC. So more than 50% soil is retained on 75 micron ISC. So it is called as coarse grained soil. So 30% of soil passes through the 4.75 ISU. So 30% passes. That means 70% is retained. So 70% more than 50% is retained on 4.75 MMCU. Hence it is called as gravel. So two categories are given. Cu value is given, Cc value also given, liquid limit also given, plastic limit also given. So this is the condition means the fines is less than 5%, in between 5% and 12%. So fines are less than 5%, then it is called as clean. If fines is greater than 12%, it is called as gravel with fines. Here the condition is in between 5 to 12%, so that we need to check both the one. So first I am checking the clean gravel. So Cu value is equal to 5, Cc value is equal to 2. Yeah, meeting well gradation requirement. So it is called as well graded gravel. Well graded gravel. Now checking the second requirement. Liquid limit equal to 28. Plastic limit is liquid limit is equal to 28. Plastic limit is equal to 25. So plasticity index is equal to 3. So plastic index is less than 4. Hence it is called as silt. So dual symbol. Well graded gravel, also silty gravel. The soil is classified as well graded gravel, also silty gravel. So GW hyphen GM. So this is about classification of coarse grain soil. Now I am taking the second one, classification of fine grain soil. So when the soil is classified as fine grain soil, when more than 50% of soil passes through 75 micron ISU. So already here I have discussed. So if more than 50% of soil passes through 75 micron ISU, then the soil is classified as fine grained soil. Fine grained soil. So let us go for classification. So fine grained soils are classified into three categories: clayey soil, silty soil, and organic soil. So fine grained soils are divided into three categories: clayey soil, silty soil, organic soil. So clay soil, depending upon the liquid limit, it is classified into three categories. If the liquid limit is less than 35%, it is called as low compressible clay, Cl. If the liquid limit is less than 35%, it is called as low compressible clay. If liquid limit is in between 35 to 50, it is called as intermediate compressible clay. Intermediate compressible clay. Liquid limit is 35 to 50. If liquid limit is greater than 50%, it is called as highly compressible clay. Highly compressible, more settlement. It will experience more settlement. So depending upon the liquid limit, the soil is classified into three categories: low compressible, intermediate compressible, high compressible. When it is called as low compressible, when liquid limit is less than 35%. When it is called as intermediate compressible, when liquid limit is 35 to 50. So when it is called as highly compressible, when liquid limit is greater than 50%. So similarly, silty soil, low compressible silt, medium compressible silt, and high compressible silt. Similarly, organic soil, low compressible organic soil, medium compressible organic soil, high compressible organic soil. So here Cl, Cich, Ml, MI, OL, OH. So silty soil, first letter S. Sandy soil also first letter S. But silty soil always expressed in terms of M with the letter M. This is because in Latin word silt is called as mist in Latin. Actually, soil is derived from Latin word solium. In Latin, solium means soil. So Latin word from Latin word solium, soil is derived. So soil is derived from Latin word solium. Similarly, mist in Latin language, the silt is called as mist. Mist. So generally we follow that Latin language. That's why in soil mechanics, silt is indicated by first letter M, mist, MIS, mist. Otherwise, for silt we need to use S, for sand also we need to S. So it become confusion to understand whether it is a silt or sand. So that's why silt is expressed by the letter M. M stands for mist. Mist is a Latin word. So it is derived from Latin. So here organic soil and inorganic soil. How can we differentiate? This is very important. So when it is called as organic soil, when it is called as inorganic soil. So for that, so first you need to find out the liquid limit without oven drying. So without any oven drying, without keeping the sample in oven, find out the liquid limit. So let us imagine it is 100%. Next, oven for 24 hours the sample should be oven dried. After 24 hours oven drying, again find out the liquid limit. Suppose if the liquid limit is 70%, so find out the 75% of initial liquid limit. So what is the 75% of initial liquid limit? 75 by 100 into 100, 75%. So here after oven drying, liquid limit is 70%. That means decreases more than 25% of initial liquid limit. So after oven drying, if the liquid limit is reduced to more than 75% of its initial liquid limit or decreased by, here two words you need to understand. Decreased by 25% equal to reduced to 75%. Both are equal, same equal meaning. Reduced by 25%. That means the value is 75. Reduced to 75%. Here also the value is 75%. So both are same. So after oven drying, if the liquid limit is reduced by 25% or reduced to 75%, it is called as organic soil. Here after oven drying, the liquid limit is reduced to 70%. That means reduced by more than 25%. That's why the soil is called as organic soil. Otherwise it is called as inorganic soil. So if liquid limit reduces more than 25% of initial liquid limit after oven drying, the soil is treated as organic soil. So in order to find out whether the soil is organic soil or inorganic soil. So we need to find out the liquid limit before oven drying and after oven drying. So after finding the liquid limit before oven drying, after drying, compare with 75%. If the liquid limit is reduced more than 25% of the initial liquid limit, then the soil is classified as organic soil. Otherwise, suppose, imagine before oven drying liquid limit is 100%, after oven drying liquid limit is 80%, then it is called as inorganic soil. Inorganic soil because 25%, more than 25% should be reduced, but here 20% only reduced. So if it is 80%, so like that we need to understand. So Arthur Casagrande has given plasticity chart to classify the fine grained soil mass. So in in plasticity chart, the chart is drawn between plasticity index and liquid limit. So plasticity index is taken in y-axis, liquid limit is taken in x-axis. So please follow my what I am saying. Very important. So plasticity index is taken on y-axis, liquid limit is taken on x-axis. Okay, here one line is there, a line, Arthur Casagrande line. The line is known as Arthur Casagrande line. Casagrande developed this chart, plasticity chart. So this line height from x-axis, height of a line from x-axis is given by an equation. Height of a line equal to 0.73 liquid limit minus 20. It is not equal, it is minus. So IP means plasticity, sorry, height of a line. Height of a line from x-axis equal to 0.73 liquid limit minus 20%. So let us check. So the line starts at 20% liquid limit. Now substitute 20 in the equation. 20 minus 20, 0. 0 and anything? 0. So height of a line at 20 equal to 0. So I understand? So IP is equal to height of a line from x-axis. Okay, at 20% liquid limit, if you substitute 20, 20 minus 20, 40, that's 20 minus 20, 0, 0 into 0.73 equal to 0, height of a line equal to 0. You can see in the figure also. At 20, height of a line equal to 0. Suppose if you want height of a line at 35, then IP equal to 0.73 into 25 minus 35 minus 20. Suppose if you want height of a line from x-axis at liquid limit 50, then you need to substitute 50. 0.73 into 50 minus 20. It will give the height of a line from x-axis. Okay, so next, depending upon the liquid limit. If liquid limit is less than 35, low compressible. If liquid limit is 35 to 50, intermediate compressible. If the liquid limit is greater than 50, it is called as highly compressible. Highly compressible. H for high compressible, I for intermediate compressible, low for low compressible. Next, C for clay. If point lies above a line, if point lies above a line, it is called as clay. If point lies below a line, the soil may be two. We have two options. One is in silt, inorganic silt, or organic soil. So if point lies below a line, the soil may be two categories. One is inorganic silt or organic soil. Inorganic silt is indicated by M. Organic soil is indicated by O. So O for organic soil, M for silt. M for silt. In Latin it is called as mist. So MH means highly compressible silt. OH means highly compressible organic soil. MI means intermediate compressible silt. OI means intermediate compressible organic soil. ML means low compressible silt. CL means low compressible clay. C for clay. Ca means intermediate compressible clay. CH means highly compressible clay. So when it is greater than 50, See the liquid limit in x-axis. When liquid limit is greater than 50, the soil is called as highly compressible, CH. Below ln, mh and oh. If the liquid limit is in between 35 to 50, intermediate compressible clay, intermediate compressible silt, intermediate compressible organic soil. If liquid limit is less than 30, it is called as low compressible clay, low compressible silt. Like that, we need to differentiate. So here 7 to 4, plasticity index is in between 7 to 4 or 4 to 7. The soil is classified as Cl, Ml, dual symbol Cl and Ml, low compressible clay and low compressible silt. It should be denoted by Cl, Ml. Okay, so now I have told one sentence. If point lies above a line, it is called as clay. If point lies below a line, it is called as silt or organic soil. So suppose if point lies above a line, so there is no confusion. Definitely you can say it is a clay soil. If the point lies below a line, then we will have one doubt. How can we differentiate inorganic silt and organic clay? So already told that we need to find out the liquid limit before oven drying and also liquid limit after oven drying. Then we need to observe how much liquid limit is decreased. If liquid limit is decreased more than 25%, then the soil is organic soil. Otherwise, it is called as inorganic soil. So when point lies above the A line, when point lies below the A line, that is the question here. So when the point lies above the A line and when point lies below the A line. So in order to find where the point lies, we need to compare the two parameters. One is plasticity index, second one is plasticity and height of A line. Plasticity index and height of A line. If plasticity index is greater than height of A line, if plasticity index is greater than height of A line, then the point lies above the A line. If plasticity index is less than height of A line, then point lies below A line. So please remember, when plasticity index greater than height of A line, point lies above A line. Please remember, point lies above A line when plasticity index greater than height of A line. So in reverse, when plasticity index less than height of A line, the point lies below A line. The point lies below A line. So that is the classification system. So plasticity chart developed by Arthur Casagrande. So he drawn this chart between liquid limit and plasticity index. So he has drawn a line starting from liquid limit 20. The equation of A line is equal to 0.73 into liquid limit minus 20%. So the equation gives the height of alien from x-axis. So for example, at 20% liquid limit, height of alien equal to 0. 20 minus 20 0. 0 into anything is 0. So height of alien equal to height of alien equal to 0. Suppose at 50 liquid limit, if you calculate the height of alien, so how can we calculate? Height of alien equal to 0.73, liquid limit 50 minus 20, 50 minus 20, 30, 30 into 0.73 will give the height of a line above the x-axis. If plasticity index is greater than height of a line, point lies above the a line. If plasticity index is less than height of a line, then the point lies below the a line. So if the point lies above the a line, it is classified as clay. If point lies below the a line, it may be silty soil or it may be organic soil. In order to differentiate, we need to do liquid limit test before oven drying and after oven drying. So after oven drying, if liquid limit is reduced by more than 25%, then it is called as organic soil. Otherwise, it is called as inorganic silt. So next, depending upon the liquid limit, the soil is classified as low compressible, intermediate compressible, high compressible. If liquid is less than 35%, it is called as low compressible. If liquid is in between 35 to 50, it is called as intermediate compressible. If liquid limit is greater than 50, then it is called as highly compressible. So let us do some problems. So classification of fine grained soil. So classify the soil with the following data. So 75% of soil passes through 75 micron ISU. So 75% more than 50% of soil is passes through 75 micron ISU. So the soil is treated as fine grained soil. So liquid limit is equal to 57, plastic limit is equal to 20. So first find out height of a line 0.73, liquid limit minus 20%. So 0.73, liquid limit 57 minus 20. So height of villain equal to 27.07. You can see in the figure. So height of villain at 57, liquid limit equal to 27.01. Now find out the plasticity index. So plasticity index is equal to liquid limit minus plastic limit. So liquid limit 57 minus plastic limit 20. So plastic limit 20. So 57 minus 20 equal to 30. So plastic limit equal here is 27. Take it as a 27. I have taken in the problem as 20. So it is at 27. So 57 minus 27 equal to 30. So plasticity index is greater than height of A line. So point lies above the A line. So plasticity index is greater than height of A line. Height of A line equal to 27.01. Plasticity index is equal to 30. So the point falls above A line. So liquid limit is greater than 50. Liquid limit is 57. It is greater than 50. So highly compressible. Point lies above A line. It is a clay. Liquid limit is greater than 50%. Highly compressible. Now the soil is classified as clay with high compressibility or high compressible clay. High compressible clay. So here one small correction is plastic limit is 27. So please correct as a 27, not 20. So second one. So classify the soil with the following data. 60% of soil passes through 75 micron ISU. So 60% of soil passes through. That means more than 50% of soil passes through 75 micron ISU. So it is called as fine grained soil. Liquid limit equal to 40%, plastic limit equal to 28. So first to find out height of A line 0.73 into liquid limit 40 minus 20 14.6. Next plasticity index liquid limit minus plastic limit. So 40 minus 28 12. So height of A line greater than plasticity index. So point falls below A line. Point falls below A line. So here no data regarding liquid limit before oven drying and after oven drying is given. So the soil is treated as inorganic silt. The soil is treated as inorganic silt. Suppose if it is given liquid limit before oven drying, liquid limit is after oven drying is given, then we can treat it as a organic soil. Then we need to check. So here no such data is given. So directly we can assume that it is a silty soil. Here liquid limit equal to in between 35 to 50. So it is a medium or intermediate compressible. So it is falls below the A line. No data is given regarding liquid limit before overwintering, after overwintering. It is assumed as silt. So the soil is classified as intermediate compressible silt. Intermediate compressible silt. Next, classify the soil with the following data. 30% of soil is retained on 75 micron ISC. So 30% of soil is retained on 75 micron ISC means 70% of soil is passes through 75 micron ISC. So it is called as fine grained soil. Liquid limit equal to 30%, plastic limit is equal to 27. So liquid limit after oven drying equal to 20%. So here he has given liquid limit after oven drying equal to 20%. Before oven drying equal to 30. So first find height of A line 0.73, liquid limits minus plastic limit. So 30 minus 27 equal to 7.3. So plasticity index is equal to liquid limit minus plastic limit. So 30 minus 27 equal to 3. So height of A line greater than plasticity index. So point falls below A line. So it may be organic soil, it may be silty soil. Now we need to differentiate whether it is organic soil or whether it is a silty soil. So 75% of initial liquid limit equal to 22.5. But after oven drying, liquid limit equal to 20%. That means so generally 75% of initial liquid limit is 22.5. So if it is after oven drying, liquid limit is more than 22.5, it is called as inorganic silt. But here the liquid limit is 20. That means more than 25% is reduced. 75% means 22.5. But more than 25% is reduced. Reduced below 75%. Hence it is called as organic soil. So the liquid limit is equal to 30, that means less than 35, hence it is called as low compressible. So low compressible organic soil, the soil is classified as low compressible organic soil. So another one, for a fine grained soil, liquid limit equal to 20% and a plastic limit equal to 14%. Classify the soil as per IS classification. So liquid limit, the difference between liquid limit and plastic limit equal to 6%. So the plasticity index lies between 4 to 7. So now come to figure. So 4 to 7. If the plasticity index is in between 4 to 7, the soil is classified as CLML. CL low compressible clay, low compressible silt. CLML, the soil is classified as CLML. So don't go for checking height of valen as well as plasticity index. So directly you can say that it is because plasticity index is in between 4 to 7. So directly you can say that the soil is low compressible clay hyphen low compressible silt, dual symbol. Suppose if point exactly lies on A line, then if point lies exactly lies A line beyond 50, so then we need to use a dual symbol CHMH or CHOH, dual symbol. Suppose if in between 35 to 50, if point lies exactly on the A line, then we need to give a dual symbol CIMI or CIOI. Suppose less than liquid limit less than 30%. If point lies exactly on A line, then we need to give dual symbol CLML. CLML. Suppose if point lies exactly on this vertical line, suppose exact you can see a dotted line here. So above A line, if point lies on the dotted line, then we need to give a dual symbol CICH. CICH. At the same time, MIMH or OIOH. Like that, we need to give dual symbol. So this is about Indian soil classification system. So we have two Indian classification system. One is based on particle size only. So based on particle size only, we have one Indian soil classification system. In this classification, we don't consider the plasticity index. That means we don't consider the liquid limit, plastic limit, atomic limits we don't consider. But another soil classification system, that means this one. Another soil classification system, we will consider particle size as well as Atterberg limits. We will consider particle size as well as Atterberg limits. So we have two types of Indian soil classification system. So actually, Indian soil classification is derived from Unified Soil Classification System. It is derived from Unified Soil Classification System because Indian soil classification system similar to Unified Soil Classification System. The classification of coarse grained soil in Indian soil classification system as well as in Unified Soil Classification System both are same. But in the case of classification of fine grained soil, there is some difference exist. The difference will be exist. So that's why it is similar to Unified Soil Classification System, but according to Indian situations, the classification of fine grained soil is modified. So Indian soil classification system is derived from Unified Soil Classification System. The classification of coarse grain soil is same in both the cases, unified soil classification system and Indian soil classification system. But in Indian soil classification system, the fine classification of fine grain soil is changed. So according to the Indian situation, Indian terrain, so the classification changed. So please remember, Indian soil classification system is derived from unified soil classification system. So this is about soil classification. So if you have any doubts, you can ask now. Chetan, Chetan, any doubts, Chetan? Do you have any clarifications? Nitin,
No, sir, no doubt, sir.
Nitin, Nitin, Prajit, Prajit, Nikhil Sai, Nikhil Sai.
No, sir.
Okay. So thank you very much for attending class. So next class I will discuss permeability and shear strength. So thank you so much. Pawan, Pawan 146 ఎవరు? Chetan, Pawan 146 ఎవరు Chetan?
సార్ మా క్లాస్ అయితే
ప్రజెంట్ మీ
కాదు సార్.
క్లాసా? రెడ్డి పవన్ మన క్లాసే కదా?
రెడ్డి పవన్ 127 సార్.
146 ఎవరు? ఇది గూగుల్లో వెళ్తుంది అది.
థర్డ్ ఇయర్ వాళ్ళేమో సార్.
థర్డ్ ఇయర్ వాళ్ళ? ప్రజిత్, ప్రజిత్, ప్రజిత్